Good afternoon. My name is Nathaniel P, and today we will be going through a conventional way of drawing different compounds based upon their IUPAC names. So this may seem intimidating at first because of all this complicated naming convention. However, it's very methodical. You just have to follow through with the steps that I'm about to present. So for starters, we have ethoxy propane. So if you had memorized the different prefixes for the different amounts of carbons per your alkanes, we should know that pro means 3. So if we do the first one here, we have our 3 carbons, 1, 2, and 3. So this is the propane part. Now I'm going to put an oxygen here, and then that will be my ethoxy propane. So we have 1, 2, 3 carbons making our propane on the left-hand side. And then we have our ethoxy group right here, our ethyl group attached to our oxy group, oxygen. And this is the entirety of that molecule. So moving on to 3 chloro, 4 ethyl hexanoic acids, quite a mouthful, but just bear with me here. So we see our prefix hex meaning 6. So we're already should be thinking 6 carbons. Look for the Greek prefixes first and go from there. So hexanoic acid. So every time you get an anoic, we know that we are looking for a oxygen double bond to a carbon OH group. So we know that this is an acid of some sort, and there's a carbon right here. So this will be our first carbon in the hexane. So 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. All right, this takes care of the hexanoic acid part. Now to take care of the subgroups, we have 3 chloro and 4 ethyl. So we want to start numbering our carbons. We have our first one because we want to start on the most fun carbon, the one with the most going on. 2, 3, 4, 5, 6. So now all we need to do is plug in our other subgroups at the correct locations. So 1, 2, 3, this is my 3rd carbon, and I am going to attach my chloro group right here, just a simple chlorine to the 3rd carbon. And now I'm going to attach an ethyl group, another ethyl group like this, 2 carbons to the 4th carbon. So it's going to look something like this in the end, minus the numbers. So this takes care of our 3 chloro, 4 ethyl, hexanoic acid. All right, moving forward. Now we have N,N-diethyl butanamide. So we should already be seeing but as in 4 carbons. And then amide is a group that's O, double bond to a C. That's bonded to an N, OCN, as such. So this takes care of the amide group. And branching off from there, we want a butane. So 1 carbon, 2 carbons, 3 carbons, 4 carbons. So this takes care of our butanamide. Now we want to put ethyl groups somewhere on this molecule. How many ethyl groups do we have? 2. So that's diethyl. And these ends right here are saying that these ethyl groups will go on the end. So ethyl groups, 2 carbons, place them on the end as such. So hopefully after going through these, you have a great understanding of how to systematically approach IUPAC drawing problems. And if you just follow the rules for them, they are very easy and straightforward, especially if you do lots of repetition. I hope you enjoyed this lesson. Please feel free to contact me at my Wyzant page listed below if you would like any further guidance. Thank you so much.